Hello, this is Mr. Huber. In this lesson, we're going to learn about solving systems of equations by substitution. Remember, substitution is when you replace something with what it's equal to. You substitute something in for something else. Typically, we substitute something in place of a variable. For instance, when we saw evaluating expressions previously, we can substitute into an expression if we want to evaluate n plus 6 and n is equal to 3. If we know what something is equal to, we can substitute that in for what it's equal to. So if n is equal to 3, we can replace and substitute the n with a 3. So we'd have 3 plus 6, which would come out to 9. As we can evaluate by replacing something with what it's equal to. Whatever n was equal to. If n was equal to 5, we replace the n with a 5. If n was equal to y, we could replace the n with a y. We can replace whatever it's equal to. And we can use that to solve a system of equations. So how do we do that? Well, there's a couple steps in the process. First, we want to solve one of the equations in our system, because remember, a system is more than one equation in the same two variables. So once we solve one of the equations for one of the variables, we can substitute that value in for the variable that it's equal to. Okay, you can solve either of the two equations for either of the two variables. Once you get x equals something, y equals something, n equals something, whatever it is, we can replace that now expression. Instead of just having n equals 3, it might be n equals 3 plus x. We can replace the n with 3 plus x. We can replace something with what it's equal to. And then we'll have an equation with only one variable, which we can then solve for that variable. After we solve for x or y, we can plug that back in to solve for the other of the two variables. So again, we're going to start by solving one of the two equations for either variable. Then we're going to substitute the expression that we get into the other equation for that variable. So whatever a variable is equal to, we can replace it with that value. And then once we know what one of the variables is equal to, we can replace that in the other equation, back in the original equation, to find the value of the second variable. So we'll have both values. We'll have an x and a y, typically. We could be on the other letters we want, but typically we're going to see it as x and y. So let's see what that looks like in practice. We're going to solve this system by substitution. Remember, the first thing we want to do is get either of the two equations solved for either of the variables. In this case, we already have an equation solved for one of the variables. Y is already equal to 3x plus 2. We already have the y by itself. We'll see that's not always the case, but in this case, we have a y equals. So we can replace the y in this other equation with what it's equal to. We're going to take the 3x plus 2 and substitute it in for the y. Just like before, we had n equaled 3, we replaced the n with a 3. Well, now I can take 3x plus 2 and I can replace it with y, because the y is equal to 3x plus 2. So I'm going to get x plus 2 and then times y. So times 3x plus 2 equals 11. You'll notice here we took this second equation and all I did was replace the y with what y is equal to. Just like if y was 5, I'd replace the y with a 5. If y is equal to 3x plus 2, I replace the y with 3x plus 2. And now I have an equation here in red that only has one variable. The only variable here is an x, which means I can solve for that variable. Anytime you have an equation written in just one variable, we can solve for that variable. So I'm going to have x plus 6x plus 4 equals 11. Then I can combine my like terms. I'm going to solve this equation. I can simplify. I get 7x plus 4 equals 11. Then I can subtract 4 on both sides. And I get 7x equals 7. Then I divide by 7. And I get x equals 1. So we solved one of the equations for one of the variables. It was already done for us. Then we replace that into the other equation and solve for the value of the variable. Then you'll recall the next step is to take that x equals 1, plug it back into either of these two equations. You can replace this x with a 1 or this x with a 1. It doesn't matter. I'm going to choose the first equation here, and I'm going to replace the x now with what it's equal to, which is 1. So I can take y equals 3 times 1 plus 2. Y equals 3 plus 2. Y equals 5. I'm going to write my final answer as an ordered pair. It's 1 comma 5. If I graphed those two equations, they would intersect and cross at that point 1 comma 5. Write it as an ordered pair, x comma y. Our solution for the system is x is equal to 1, y is equal to 5. We could check that. We could take this and plug it back in to both equations. Make sure it solves both equations, right? The solution should be the only ordered pair that works in both of those equations, 1 comma 5. Let's see some more systems here and solve those. So we've got a system here of two equations. 4x plus 6y equals 4, and x minus 2y equals negative 6. So in this case, we don't have a variable already by itself. So we need to get one of these equations solved for one of the variables. You can solve either equation for either variable. I would suggest here where we have an x with no coefficient written down, so that means it's just a 1 here, I would try to get this x by itself, because that's going to be the least work. We're not going to have to divide by anything here. If I subtract 6y on both sides, I'm going to have to divide everything by 4. I'm going to end up with some fractions to get the x by itself or get the y by itself. So in this case, the probably best option would be to add 2y, because now I've got x equals 2y minus 6. So I've got the x by itself. That means now I can take this and I can substitute it into the other equation for the x. So I'm going to get 4 times 2y minus 6 plus 6y equals 4. Okay, right, I replaced the value of the variable with what it was equal to. In this case, the variable was equal to 2y minus 6, so I replaced the x with 2y minus 6. And now I can solve this equation, because I only have one variable left, I have a y, so I can distribute. I'll get 8y minus 24, 8y minus 24 plus 6y equals 4. Okay. Then I can combine my like terms. I get 14y minus 24 equals 4. And then I can add 24 to both sides. And I get 14y equals 28. And when I divide by 14 on both sides, I get y equals 2. And now I can substitute back into one of my original equations. Go back to here, one of these two original equations. I get y equals 2. Either replace this y with a 2 or this y with a 2. It does not matter which equation you use. Again, it should be the same. When I plug y in here or here, I should get the same thing for x, because there's only one x and y that should be a solution for this system. So I'm going to choose that second equation, and I'm going to replace the y with a 2. So I'm going to have x minus 2 times 2 equals negative 6. That's x minus 4 equals negative 6. And then when I add 4 to both sides, I'm going to get x equals, I already had the y, x equals negative 2. So my final answer is going to be negative 2, comma 2. Again, I could check that by taking negative 2 and 2 and plug it in for x and y. Plug it in here, I get to put a negative 2 in for x, I put a 2 in for y, I get negative 2 minus 4, that'd be negative 6, equals negative 6. I can come back up here, I could do 4 times negative 2, which is negative 8, plus 6 times 2, which is 12, so I get negative 8 plus 12, which is 4, equals 4. It worked. It solved both equations. So we can plug it in, make sure it's a solution for the system, for both equations in that system. Right. You should be trying these now too as well when you look at this equation. Let's try it out. See if you can get one of the variables solved by itself. See if you did that part right. Then go to the next step and see how you're doing as you go through. Okay, hopefully you've tried to solve one of these two equations for one of the variables, and you may have done it a little differently. So I may show something and you do it a little differently, and that's okay, because I can solve either of these two equations for either variable. It doesn't matter. I'm going to take this first equation, I'm going to solve it for y. Okay, so I'm going to subtract the 6x and divide 2. So we'll see what that looks like. Okay, when I do that over here on the side, I first would subtract 6x on both sides, so I get 2y equals negative 6x minus 14. Then I'm going to divide by 2 on both sides. So I divide by 2, I get y equals negative 3x minus 7. Okay? And now I can take that and I can plug it in here for y, because I know what y is equal to. I can substitute it into the other equation. I get negative 2x minus 3 times negative 3x minus 7 equals 0. Careful with negative signs here. When I'm distributing a negative 3 into the parentheses, I'm going to have negative 2x plus 9x plus 21 equals 0. So I'm distributing a negative 3 into the parentheses there. So I have 7x plus 21 equals 0. I can subtract 21 on both sides, and I get 7x equals negative 21. Divide by 7 on both sides and get x equals negative 3. So I got x equals negative 3, which then I can plug into either of the two equations. I'm going to pick the second one. It really doesn't matter a whole lot. If one of them looks a little easier to work with, then pick that one. So I get negative 2 times negative 3 minus 3y equals 0. That's going to be 6 minus 3y equals 0. Then I'm going to add 3y to both sides. Or you can subtract 6 on both sides, right? It doesn't matter. So I do the same thing on both sides of the equation. I get 6 equals 3y. I just like not to have negatives if I can avoid it, because that way there's less chance to make a mistake with those things. I get 2 equals y. So my final answer is going to be x is -3, y is 2. That's the solution for that system. Find one of the two equations to solve for one of the variables. Doesn't matter. Either equation for either variable. Then when you know what a variable is equal to, you can replace it with what it's equal to. Right? Substitution. You can substitute something for what it's equal to. And then do substitution again after you solve for the first variable to get your second variable and get your x and your y. Write it as an ordered pair, x comma y. All right, before we see an application type problem, a little bonus biology-wise. All right, the length from your wrist to your elbow, the wrist to your elbow, so that kind of forearm area, it's the same length as another part of your body. And it might be slightly off, but in general, the proportion's there. So that's the same as the length of your foot. Your foot is the same length as the distance from your elbow to your wrist. Yeah, typically. Don't go hurting yourself trying to stick your foot up to your forearm right now, falling out of your chair or anything like that. Now let's see what we can do to write a system of equations, then use those to get our solution. So we've got two fitness centers here. We've got Pump It Up. All right, so we're going to Pump It Up. They are offering $19 registration and $45 per month. So what could the equation look like for that? Let's write it out. So I'll just put pump for Pump It Up. We'll have y as the total cost is equal to, right, think of an mx plus b, a rate of change and a starting amount. So our rate of change is $45 per month, okay, plus the $19 registration fee, okay, so that's Pump It Up. Then we've got New U, so New U Fitness Center is going to be y equals $18 per month, okay, plus a $100 registration fee. Right, so there's different cost structure there for each place. So we're going to write and solve a system. So as we did, we wrote a system of equations. We wrote two equations in the same two variables for this situation. Two different equations with the same two x and y, x being number of months and y being the total cost. So let's put up here, x equals the number of months and y equals total cost. Okay. So now to substitute, well, we know the first equation solve for y, so is the second one, so you could replace either one into the other equation. 4x plus 19, I can replace the y with 4x plus 19. So I'm going to have 45x plus 19 equals 18x plus 100. And now I could solve this equation. I can subtract 18x on both sides. So that's going to give me 27x plus 19 equals 100. Then I can subtract 19 on both sides. Okay, and when I do that, I'll give myself a little bit of room here to do this work. Right, we're going to get 27x equals 81. Then we can divide by 27, and I'd get x equals 3. And I could plug that in. Let's check it. Let's plug it into both of these equations. So in the first one, for Pump It Up, we're going to have y equals 45 times 3 plus 19. So 45 times 3 is 135 plus 19, that's 154. Then I'm going to plug it into the second equation. I'm going to get y equals 18 times 3 plus 100. 18 times 3 is 54 plus 100, so 154. And they come out the same. That makes sense. We'd have 3 comma 154. What does that actually mean for this situation? It says find the number of months for both total costs to be the same. So at 3 months, the total cost would be the same. And it would be $154. So after 3 months, either place, you're going to spend a total of $154. Right? So we wrote a system of equations, and we solved it. Each of these times, these equations, they looked a little different, but the goal at first is to get one of the equations with one of the variables by itself, solve for some expression that you can plug into the other equation, solve for the resulting one variable you have left. Once you know the solution of that first variable, whichever it is, you plug that in to find the value of the second variable, and then you've got your solution for the system of equations by substitution.